Welcome to the second part of this IoT tutorials on IoT and embedded cybersecurity. So in our previous video, we learned how to set up our Raspberry Pi Pico kit and the Pico-W. So in this video, I'll be talking about the simple IoT project that is titled IoT-based temperature and humidity monitoring and control system. So basically, it's a simple IoT device that enables real-time sensing of environmental condition using the DHT11 sensor, and also it allows remote control of electrical devices through a relay via the internet and mobile devices. Okay. So what are the applications? So it can be applied in smart homes, agricultural purposes, for example, the greenhouse, or you can use it to monitor your poultry or your brooders, your brooding system, or you can also use it to monitor your fish farms, your ponds. You can also use it to monitor your storage facilities. It can be used in air care centers, server rooms, classrooms, offices, and even industrial environments. Okay. Now let's look at the components that are required to build this simple IoT environmental controller. So we need the Raspberry Pi Pico-W or Pico-W. We need the USB cable. Okay, this is the USB cable. We need the OLED, so we're using the OLED 0.9 inches OLED. We're also using the DHT11 sensor. So this sensor measures the temperature and humidity. We need our MICROPYTHON Pico development kit. Okay, so this is the MICROPYTHON Pico development kit. And we need a single channel 5 volts relay. Of course, you can use multiple channels, but for this simple IoT project, we're using the single channel relay. Of course, we need our jumper cables. Okay. And now, once we've identified our components, we need to do what is called pin mapping. That is the table that describes which pin of the Pico-W is connected to our electronic component. So in this case, I've listed all the pins of the Pico-W. So the GP0 is connected to the OLED SDA pin. GP1 is connected to the OLED SCL pin, and of course the OLED VCC is connected to the 3.3 volts output of the Pico-W, and the OLED ground is connected to the ground. The same thing applies to the DHT11. So we're using the GP2 to connect to the DHT11 signal pin, and 3.3 volts to power our DHT11, and of course ground to ground. So we have a passive buzzer on the MICROPYTHON Pico development kit, which is connected to GP18. So we're using GP18 there. Then the relay is powered with 5 volts. So we're connecting to the V bus of the Pico-2 microcontroller. Then of course ground to ground, and the relay in, that is the signal that controls that receives commands from the microcontroller. So we're using the GP6 to connect to the relay in. So the GP6, the microcontroller sends out a signal from GP6 to switch on the relay or switch off the relay. So this is the hardware design. Okay, so this is our OLED. So this is the ground. So the ground is connected to this ground of the Pico-2 microcontroller. VCC, as you can see, is connected to 3.3 volts. So this pin is the 3.3 volts output that powers any device that is powered by 3.3 volt. Then of course the SCL is connected to GP1. SDA is connected to GP0. All right. For the DHT11, this is the connection. Okay, so we have our signal out, which is connected. The VCC is connected to 3.3 volts of the Pico-2 microcontroller. The signal out, which is S here, so most times they put this symbol S. Okay, so you connect it to GP2 of our microcontroller. Then the buzzer, so it's connected to GP18 of the microcontroller. Okay, and this to ground. Okay. Then we have the relay. So the relay, the signal in, so GP6, GP6 is connected to the signal in, all right? And the ground to ground, because VCC to 5 volts, all right? So these are the hardware circuit connection. So using your jumper cables, the groove. So this is connected to groove 1. So if you look at your MICROPYTHON Pico board, you see GP0, GP1, 3.3 volts and a ground. So you just connect them directly to your OLED. Okay, so GP0 is on groove 1. That's how I'm using groove 1. So they are all labeled. That's the beautiful thing about this development kit. So it's all labeled and easy to use. Then the buzzer, the DHT11. Okay, so we're using this groove 2. Why? Because it has the GP2 connected to this white jumper cable. Then of course our relay is connected to the 5 volt. Okay, so in this case we're using a female to male connector, okay, or jumper cable. So this goes into the relay, and of course we use the header pins on the MICROPYTHON Pico development kit for the connection. So I'm going to show you next a video tutorial on how to set the connection up. Okay, so we're going to set up our IoT temperature controller. So we have the relay, 5 volt relay, we have the MICROPYTHON Pico base development kit, we have the OLED, we have the DHT11 temperature sensor, and we have our Pico-W microcontroller. Then we have our jumper cables for connection. So let's do that quickly. So the first thing is for us to insert the Pico-W into our Raspberry Pi, into our MICROPYTHON Pico development kit. And again, so you check your USB port, then you insert nicely. Okay, so this is done. So the next thing is we're going to connect our OLED. Okay, so the OLED has 4 pins. That's 4 pins. We have the ground, VCC, SCL, and SDA. So we're going to use one of these groove connectors. So connecting the female part into the male headers of the OLED. So first is the ground. Okay, so the ground is usually the black one. So you take your black one and you connect to this point. Then the next is VCC. So make sure you note the VCC position, and the red cable usually is used for VCC. Okay. Then the next is SCL. So SCL, I'm going to hold on that because I need to be sure which of the GP zeros, because our SCL is meant to connect to GP1 and SDA is meant to connect to GP0. So I'll come to my board here and look for which of them has GP0. So GP0 is on groove 1. So you have groove 1. Okay. So I'm going to connect this to my groove. Again, the groove has a clip, so you press it down a bit and you insert it nicely. Okay, so that's done.